All right, here we go. Here are some highlighted notes that I want to go over for this first day of second semester as we look at 5.6 and 8.1 and 8.2. So I'm just going to go in order, all right? And I'm not going to go over every single little thing. You do have um, the note solutions, and so if you want to, take a look at that. But I'm going to try to highlight what I feel like are some important parts of these sections. Okay. All right. So here we've got two theorems. Okay. The longest side of a triangle is opposite the largest angle. Okay. Um, and similarly, the shortest side of a triangle is opposite the smallest angle. Okay. So that relationship always exists. Okay. Um, and on the flip side, the largest angle is opposite the longest side. Okay. In any triangle, that is always going to be true. Okay. So just as a quick example here, I know there are two triangles here, but I'm going to focus here on triangle CDB, right? We figured out that angle C is 38, and so clearly 110 is the largest angle. So therefore, um, this side, CB, is going to be the longest side, right? 32 is the smallest angle, and so therefore the side across from it, or opposite, CD, that's going to be the shortest side of the triangle, all right? And 38 is the middle angle, right? And so the side DB across from it is going to be the medium length, all right? Okay, so just some quick examples here. Okay, like in example one, it says list the angles in order from smallest to largest, and in number one, you are given the side lengths, right? And so the smallest angle is going to be angle C because it's across from the shortest side, 6, right? And then comes angle B because 9 is in between 6 and 13. And then angle A is the largest angle because it's across or opposite from the longest side, right? That's why in a right triangle, the hypotenuse is always the longest side because it's always across from 90 degrees, the largest angle in a right triangle, right? Because we know that the other two angles are always going to be smaller than 90 degrees, okay? Now, obviously you might have an obtuse triangle, okay? But for a right triangle, that's why the hypotenuse is always the longest side. All right. And here it's the other direction, right? If you know the angles, then list the sides in order from shortest to longest. Okay. All right. This is another theorem and relationship that holds true in any triangle. The sum of the lengths of any two sides is greater than the length of the third side. Okay, and so here A plus B is greater than C, and notice it's not greater than or equal to, it is strictly greater. Okay, and then B plus C has to be greater than A, and A plus C has to be greater than B. If one of these inequalities does not work, that actually means that a triangle is not possible, right? Um, Given the measurements that you might have, okay? And so you might not be able to complete a triangle, right? So here in example 9, right, here it is. 1 plus 1 is not, it's equal to 2, but it has to be greater than 2. And so this actually means you cannot draw a complete triangle, okay? Um, and so here, um, like in number 10, we don't even give you a picture of a triangle, just given the sides here, right? Okay. Um, Numbers 11 and 12 are probably good ones to look over. if you're given two sides, then what are the possibles for the third side, right? Well, we know that the maximum it can be is going to be 16, right? And then the minimum is going to be, if you subtract those numbers, it's going to be 6. Okay. This was part of like if we were in class, we would probably do this. If you look at the notes, we would probably go over this little warm-up activity with Homer Simpson. And now, we're in 8.1, and this is mainly a review of the Pythagorean theorem. Okay. This is just a warm-up. Part of it is also going over simplifying square roots. Okay, so hopefully we remember how to do that. Okay. And we remember the Pythagorean theorem is a squared plus b squared equals c squared, right? For any right triangle, where c is the hypotenuse. Okay. There's also this relationship here. All right. C represents the longest side. Okay. If you do a squared plus b squared, and it's greater than c squared, that means the triangle is actually an acute triangle. And if a squared plus b squared, if that sum is still less than c squared, the longest side, then it is an obtuse triangle. All right. And so this little box here would be very, very good to know. Okay. There's also what's called Pythagorean triples. All right. Pythagorean triple is any three whole numbers that satisfies the Pythagorean theorem. Right. Leg squared plus leg squared equals hypotenuse squared. Right. 3, 4, 5 is the most basic Pythagorean triple because 3 squared plus 4 squared equals 5 squared. All right. And then any multiples of 3, 4, 5. Right? So if you multiply by 2 each of those numbers, 6, 8, 10, that means 6 squared plus 8 squared equals 10 squared. If you multiply by 6, right? And so on. Okay. 3, 4, 5 is a Pythagorean triple. 5, 12, 13 is another one. 5 squared plus 12 squared equals 13 squared. 8, 15, 17, and 7, 24, 25. These four are probably the four most popular or smallest Pythagorean triples. Okay, so those are good to know. All right, now if you don't recognize that in a drawing, that's fine. You just need to do the Pythagorean theorem. Okay. Here I just put these on here because I wanted to highlight. You got to remember how to factor. Okay, and double distribute. Some of your teachers might have called it FOIL. All right. I want to specifically highlight here, okay, what you cannot have a square root in the denominator, right? And so what do? How do we get rid of that square root sign? We go through this process called rationalizing. And so whatever the denominator is with the square root, since this is a square root of 3, I'm going to multiply down here and up here by a square root of 3. And really, it's really multiplying by 1, right? But whatever that denominator is, that's what you're going to multiply the top and the bottom. Because on the bottom, now what you get is square root of 3 times square root of 3 is a square root of 9, which is just 3. Okay, so there's kind of a rule in math that you can't have a square root in the denominator. Right, so in 8.2, we actually get into 45, 45, 90, and 30, 60, 90. And this is one of the topics in summer school that I really wish that we could spend a lot of time in because these ideas are going to keep coming up in math. Okay. The warm-up here, the Pythagorean theorem, actually these problems relate to these theorems here. Okay. So 45, 45, 90 triangle means 45 degrees, 90 degrees. And there's a special relationship here. These are not 5s, these are S's, okay? If it's a 45, 45, 90, it's an isosceles triangle, which means we know that the two sides here are going to be congruent, okay? So the theorem is kind of a shortcut, right? Instead of working out the Pythagorean theorem, if you know it's a 45, 45, 90, and if you know that these two are the same, then the hypotenuse is going to be whatever that number is times root 2. You just attach a root 2. Okay, so what this means here is if you have the legs, and if you're trying to figure out the hypotenuse, you multiply by root 2. Vice versa, if you have the hypotenuse and you're trying to figure out the legs, you simply divide by root 2. Okay, and so these examples here show that, right? In example 1, you're given 8 and 8. You could do, if you really wanted to, 8 squared plus 8 squared equals x squared and then figure it out. But since we know it's an isosceles triangle, right triangle by the way, 8 and 8, then this must be 8 root 2, right? This one, this is 6 root 2. Well, the other side is a 6 root 2 because we know that these two angles are congruent, right? And then 6 root 2 times root 2, right, simplifies to 12, okay? In these examples, right, we go the other way. If you're given the hypotenuse, right, here 28, what are the legs going to be? Well, you take that number and you divide by root 2, but the problem is, like I mentioned a couple minutes ago, you can't have a square root, so you have to rationalize, okay? And so you go through this process of rationalizing and you end up with 14 root 2. Now I also like to think about it, and I hope this doesn't confuse you. If you're given the hypotenuse, you can divide by 2 and then attach a root 2. Okay, you can divide by 2 and attach a root 2. Right. So same thing here. Okay, even though it's an odd number, it's fine. Right. You take the 5, you divide by root 2. Here it is, 5 over root 2, and then you have to rationalize it. Okay. I am going to ask that you leave it as a fraction, right? So instead of writing 2.5, okay. So then here's one more example going over that, right? If you're given the hypotenuse of 16. There is also 30, 60, 90 triangles, okay? If you have a 30 degree, 60 degree, 90 degree, and there's more to remember here, okay? Remember 30 degrees is the smallest angle, so therefore the side across from it is going to be the shortest side. Whatever that shortest side is, the hypotenuse is going to be double that length, so 2s here, okay? And also whatever that side is, the shortest side, to get the medium side across from the 60 is going to be whatever that length is times root 3, okay? So the hypotenuse, SL stands for short leg, LL stands for longer leg, okay? And so here, you're given the hypotenuse here of 30. So that means, well, going backwards, the shortest side is going to be 15, half of that, right? So that goes across from the 30. And since we know this is 15, then this is going to be 15 root 3. Remember, you just multiply by root 3. Okay. Same thing for 12. All right. And this one, I believe, yeah, you're given the shortest side of 1. And so double that is going to be the hypotenuse. And then 1 times root 3 is just root 3. So that's your medium length across from the 60. All right. And this one, these are the trickier ones when you're given a medium length, right? You've got to divide by root 3, okay? And then rationalize to get your shortest length. But once you get your shortest length, you double that. So the numerator 25 here times 2, that's how we get the 50. Okay. And then 19 is a good one. It's a mixture. It's a combination of 45, 45, 90 and 30, 60, 90. This one would be a good one to go over. Okay, I know I sped through these last couple slides. And so the special right triangles, I may make another video about it. But if you have any questions, please shoot me an email.